Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Welcome to another great episode right here on IT Pro TV. You're watching the CompTIA Network Plus show. I'm your host, Ronnie Wong, and today we're going to be taking a look at part 2 on IP addressing. And here to help us once again is going to be our CompTIA master himself, Mr. Wes Bryan. Wes, welcome to the show.
Hey, Ronnie, thanks for having me. That's right, and thanks for jumping in here. It's great to have you here. That's right, we are continuing along in IP addressing part 2, like Ronnie said, and we're going to kind of pick up where we left off from part 1. Remember, we were looking at the structure of an IP address, and we were looking at the fact that it's a 32-bit identifier, right? And it's not something that, when we talk about the binary itself, that's something as humans, right? We don't easily recognize, and that's why we said in that first episode we told you about dotted decimal notation. It's what we work with, right? And it makes it a lot easier to remember an IP address if we have those 4 blocks that we called octets. Right, we call them out by their decimal notation, but that's not what your computers work with, right? The computers see only the binary, and sometimes, which we will get to, I promise you along this beaten path, we will get to the point as to why we sometimes need to do the decimal to binary conversion. All right, so let's go ahead and let's continue. In the first episode, we were looking at a series of IP addresses, and we were doing exactly that. We were doing the decimal to binary conversion, and we were just kind of going octet at a time, just so you could see. And we were hoping, our goal is that by the end of this episode, that decimal to binary conversion is going to be a thing of the past for you, and you will easily recognize how to do it. So Ronnie and I, we were talking before we started this episode. He is going to jump in here, and he'll have my calculator kind of proofread my math, because as you all have seen throughout this entire course, my math is impeccable, right? No, just kidding. It's just like my typing skills. I'm very challenged. So let's go ahead and let's take a look at my screen. If you remember in the first part, we were looking at this IP address, right? We had 208.119.38.100, and we gave you an example on how to break that down. Remember, we talked about the place values, right? We're used to that base 10 numbering system, those place values being the 1s, 10s, 100s, 1000s, right? And that's what we are used to seeing in decimal. Remember the place values. I said if there's one thing that you can memorize, if you can remember these 8 bits wide, their place values, you're going to be doing really good inside of networking when it comes to this conversion process. So we're going to go ahead and we're going to pick up right where we left off, and we're going to move into the second IP address. And let's go ahead and let's work octet by octet so that we do understand this. All right, so we're going to go ahead and we'll work with the first octet, Ronnie, and if you can help me out here, because I always have to have my math definitely checked. We're going to start. Remember that, like we said, if I can use a place value with the number or the remainder that I'm working with, that would be a true statement and becomes a binary 1. If I can't use it, it becomes, remember what I said, it's like being false, right? And that becomes a binary 0, and we take that number or the remainder and we work our way through each bit position until we get to the end with no remainders, right? We don't have any remainders in this formula that we're using here. All right, so we're going to start from our left to right, and we're going to start with 192. Now, can I use the 128 place value? And the answer is yes, I can, right? So that means it's true, and that becomes a binary 1. Then we're going to take 192, and we're going to subtract that place value and see what we get. Now, if my math is correct, if I subtract 128 from my 192, I should get a remainder of 64. Now, what are we going to do? We're going to take that 64, and we're going to move it to the next bit position, right? And we're going to ask that same question. Now, it's kind of interesting on this one, right? Remember, we said 64. If I can subtract 64 from 64, that's going to be true as well, right? So that's going to be a binary 1. And this makes it easy for us. Remember, anytime you have a remainder anywhere in these bit positions of 0, it just means that the rest of those fields are all going to be zeros, right? So since I have a remainder of 0, we can make this one kind of easy, and we can just fill these in. So if we're looking at the 8 bits, though, that octet, right, the binary 192 is going to be 11000000, right? That becomes the first octet. Remember, from left to right, first, second, third, and fourth octets. Next thing that we're going to work on is, well, 168. So we'll go ahead and we'll do that same process, and we're going to ask that same question again. Can I take my value, 168, and can I subtract the place value from it? Can I subtract 128 from 168? And the answer is yes, I can, right? So that's going to become true. That's going to be a binary 1. We're going to subtract that. And if my math is right, I believe we should have 40 left, right? And we're just gonna, again, move through the bit positions with that remainder. Now notice that when we get to, and you know what, let me take a second here and actually bump these up here a little bit so it's a little easier to see. There we go. Notice we got a remainder of 40, and when I get to the 64 place value, right, that value, I can't subtract it. So it becomes a false, and that's a binary 0. And then we're gonna move to the next position. Now my remainder is still 40, right, because I couldn't subtract 64 from it, so now I gotta take that 40, and I'm going to ask the same question. Can I take 32 and can I subtract that from 40? And the answer is yes, I can, right? So that is true. Becomes a binary 1. And if we subtract 32 from our remainder of 40, we should have 8 left. And we're going to ask the same question, right? 16, I can't use that, right? I have 8 left, so I can't subtract 16 from it. It becomes a binary 0. We move to the next place value. Again, we're going to ask that same question. I've got 8 left. Can I subtract 8 from 8? And the answer is yes, so that becomes true. And we have a remainder of 0. Make it easy for yourself on the exam. You can get to that answer faster. Once I have a 0, everything behind that is 0. No remainders in this conversion, right? All right, so now we have our first 2 octets. We got the first and second octet, just like we did in the first example of the IP address. So we're going to go ahead and we're going to work on the 131. Asking the same question, 128, can I subtract that? And the answer is yes. Yes, I can. So that's going to be a binary 1. And if I subtract 128 from our 130, I should have a remainder of 3. Now, if I have a remainder of 3, this should be kind of easy, right? I can't use these first few positions, right? So can't use 64, can't use 32, can't use 16, can't use 8. Well, geez, I can't even use 4, right? So I know the first value that I can actually, place value that I can subtract is 2, right? So we're going to take 2 and we'll subtract it from 3. We know we can, so that becomes a binary 1. Leaves me with a value, a remainder of 1, right? Well, that leaves the last place value. We got a 1 that I have a remainder, and I can subtract 1 from it, so it becomes a binary 1 as well. So you're starting to see the process, right? The process doesn't change, and like we were telling you, memorize these 8 bits, all right? So we're going to work on this, the 4th octet here in our IP address of 192.168.131.54. We'll do the same thing, and I'm going to take 128, and yes, I can subtract that from 154, so that becomes a binary 1, and I have a remainder of 26. Now, here again, we're following that same pattern here. I can't use 64, I can't use 32, so the very first one I can use, the very first place value that I can subtract this remainder from is going to be 16. And if I take 16 and subtract it from 26, well, I can use that place value, should give me a remainder of 10. All right, now that I have my remainder of 10, we move it to the next position, right? And I have 10 left, so I can subtract 8, right? That becomes a binary 1. That leaves me with a remainder of 2. Notice that I cannot use the 4, but I can use the 2, right? I could subtract 2 from 2. That becomes a binary 1, and we have a remainder of 0 in that place value, so everything else behind it is 0. All right, so we've got 2 of these IP addresses up to this point. We broke them down into what their 32 bits would be, and that's what the computer is going to see, right? We're going to do one more here, and then we'll move on, and hopefully by this time you've got a good grasp on how it is to convert these, and we'll kind of tell you too, you never know. On the exam, they might actually give you the binary, and they say, what are the decimal value? What is the decimal value for this binary number? And we'll make that easy. We'll make that kind of easy for you and show you how you can do the reverse. All right, so we're going to start with 70 here, and if you look, very first number or place value can't be used, right? I can't take 128 and subtract it from 70, right? So that becomes a 0. Giving me the first place value that I can use is 64, right? And I can subtract 64. So that becomes a binary 1. Following the same formula should give me a remainder of 6. Make it easier on yourselves. Get that answer quick, right? I know that I can't use 32, can't use 16, and I can't use 8, right? Go over to 4, and I can subtract 4 from my remainder of 6. So that becomes a binary 1. And it leaves me, if I'm right, with 2. Now, guess what? We've got a 2 place value, so I can subtract 2 from 2. And I do not put a 2 there. We put a binary 1 there. We subtract it. I've got a remainder of 0. So this becomes the next octet, right? Our first octet in our final IP address. All right, now we got 201. Same process again, guys and gals out there. Yes, I can subtract 128, so that becomes a binary 1. And if I subtract 128 from my, well, at this point, it's the starting point of 201, I'm going to get 73 as a remainder. All right, now, I got 73, so guess what? I can also use the 64 place value. And if I take 73 and I subtract 64 from it, I should get a remainder of 9. Now, that being said, make it easier on yourselves. Get to those answers quicker. Since I have 9, I know I can't use 32 and I can't use 16, but I can use 8, right? And because I can use 8, that becomes true. It's binary 1, and I take my remainder of 9 and subtract 8 from it. That leaves me a remainder of 1. Again, get to your answers quicker. I know if I've got 1 left, I can't use the 4 and I can't use the 2 place value, but I can use the 1, right? I can subtract 1 from 1, right? And that leaves me with the second octet. All right, hang on with me here. We're almost done. We're almost done with some of the math. Thank goodness this is the binary math that you need to know for some of the basics. Let's go ahead and do 10. 10 is fairly easy because guess what? I can't use 128. I can't use 64. I can't use 32. Can't use 16, right? The first place value I can use in the decimal 10 is the decimal value is going to be the 8 place value. So that becomes true, and I'm going to put a binary 1 there, and I'm going to subtract it, right? So 10, I'm going to subtract 8. I have a remainder of 2. Can't use the 4. Can use 2, right? The 2 place value, so 2 from 2, or 0. I'm going to mark it as a binary 1, and we're going to use that last place value, since I have no remainders, is going to be a 0. All right, we've come to almost the end of the road here on our decimal to binary conversion. Let's do the last octet here. All right, so we got 186 here. Now, you're going to have to help me out on this one, Ronnie. 186 minus 128. Now, I know I can use the place value. What do we got there, Ronnie?
58.
58, all right. So I can't use the 64, but I can use the 32. All right, you want to help me out with my math on here? 58 minus 32?
26.
All right, so I can use 32. All right, I got 26 left, so I know that I can subtract the 16. Even I can do this part of it, right? I'm going to subtract 16 from there. It leaves me with a remainder of 10. I can use the 8, but I cannot use the 4. Now I have a remainder of 2. That's why I can't use the 4. Be clear on that one. I have a place value here of 2, so I can subtract 2 from 2. Becomes a binary 1. I subtract that. I have a remainder of 0. Makes that last position a 0. All right. So, not really complicated once you know the steps and once you memorize these 8 bits. These 8 bits, if these place values are going to be very, very important to just understanding as you move through future calculations on how to do this conversion process. Now, the next thing I want to talk a little bit, we mentioned in the first part, we mentioned a little bit about subnet masks, right? Now, we're going to come back to exactly what a subnet mask is doing, but I want you to understand a little bit of the decimal to binary conversion on a subnet mask, if you will, all right? Because subnet masks, we didn't really mention the fact that they're not IP addresses, all right? But they always seem to follow this same type of pattern, right? And that means a subnet mask primarily is made of contiguous ones. It's made of contiguous ones from the left to the right, and you cannot have any zeros in between those ones. Let me show you what I mean here. In fact, we're going to take 3 of our common, and we'll go into this a little bit more, classful subnet masks. And again, we'll come back to classes here coming up, right? But I want you to notice that we have a 255. I want you to also keep in mind that any subnet mask has to be contiguous 1 bits, right? Well, that doesn't make sense if you don't know, see the decimal, but you don't understand the binary that's underneath. So let's go ahead and let's do that same process when it comes to a subnet mask. We're going to convert it. And I did the same thing here, just kind of put those octets stacked on each other, right? So if we take 255, can we subtract 128 from it? And the answer is yes, right? We know that. So I'm going to go ahead and do the same process here, and that should leave me with 127. Now, the next thing that we do is we move to the 64 spot, right? And I can subtract 64 from 127, so I mark that as a binary 1, and I move to the next place value. Now, if my math is right, I should have a 63. All right? So we can subtract 32 from 63. We're going to go ahead and do that, mark that bit value, place value, if you will, as a binary 1, and we move forward. Now, the next thing I have to do is, did I go too fast? I think I did too many 1s there. I do too many ones there.
You're right.
Oh, I'm right. Okay, so I can subtract 32. Got ahead of myself there. And when I do, I should have a remainder of 31. I got to keep track of where I'm at, too. Now, 31 is my remainder, and I'm looking at the 16 place value. I can subtract 16 from 31, right? So we're gonna go ahead, we'll put a binary 1 there, and we'll move to the next octet. Now, if I take 31 and I subtract 16, I should have a remainder of 15, right? And we're gonna do that. So we move to the next place value, and guess what? I can subtract 8 from 15, so that means that is a binary 1 as well. We take our remainder of 7, and we move to the next place value, right? And I can subtract 4 from 7, so that becomes a binary 1. You're going to start to see that pattern again, right? And if I subtract 4 from 7, that gives me 3 left. Well, guess what? I can subtract 2 from 3, so that also becomes a binary 1. That leaves me with 1 left, right? That's my remainder. And look, I can subtract 1 from 1. Now, I want you to notice something here. 255 is the largest number you can get in an 8-bit octet. All right, notice also that every one of these place values has a 1 in it. Now, notice the zeros here. Zeros are very easy. Those aren't too complicated, right? Yeah, that just means every place value is going to be a 0, right? And I could probably fill these out a little bit easier, but we'll go ahead and do it just cell by cell here. Now, the question is, if I were to lay these all out, right, 32 bits left to right, do we have contiguous 1 bits? Right? Do I have any zeros in between, a break in the ones, right? A 0 and then another 1. And the answer is no. And that's something to understand about a subnet mask. A subnet mask must be contiguous 1s. There cannot be any zeros in between these 1s. And we're going to come back and we're going to see how that applies to our IP address and why that's so important here in a second. Now, if we just do the same thing here, you're going to notice that 255.255.0.0, well, let's just go ahead and we'll make it easy. We'll just fill these in because we already know that they are 1s. Right? And I know that those last 2 octets are all 0s, and the question would be, well, do I have contiguous 1 bits here? Right? Do I have, if I were to lay these out all 32 bits wide, do I have 1s that are contiguous and the 1s stop and the 0s begin? And the answer is correct, right? I have 2 contiguous blocks or octets of 1s. Same thing goes here. If you will, for the last set, right, we can do the same thing here. And if you'll notice, we have now 255.255.255.0. Notice that we now have contiguous 1 bits in the first 3 octets. And the last octet, of course, being 0, all 0s, right? Now, that is important, right, because I want you to remember what a subnet mask looks like in the binary, because we're going to come back to that, and we're going to define why that's important. For now, at this point, all I want you to remember is that a subnet mask has to be contiguous 1 bits. You have to have 1s, no 0s in between, and at some point within these 4 octets, the 1s will stop and the 0s will begin, all right? Now, let's go ahead now and introduce go farther. Now that we've seen the majority of our decimal to binary, let me go ahead and tell you how you would reverse this if you needed to. All right, let's go back real quick, if we could, to the diagram. If you ever have an 8-bit binary number on the exam and they say, hey, which of in your answers are the decimal values? This 8 bits of binary, what is that in decimal? If you can remember these place values that I'm kind of harping on here, if you can remember them, all you got to do is make this chart, put those binary numbers in this chart, and add up all the 1s. And what I mean by that is take every place value that you see has a 1 in it and add it up, and you'll get your answer, right? If I look at, if I add, let's see, 16 and 64, I get 80. Right? 16, excuse me, let me try that again. 16 and 64, I get 80. And then from 80 to 128, I get 208, right? So it's easy to do the conversion from binary to decimal once you know these place values, all right? So I wanted to not skip over that, make sure that we do show you that just in case. Now, let's kind of look at an IP address. Now, we've talked about these IP addresses. We wanted you to kind of understand that it's a 32-bit identifier, right? And it uniquely identifies a node within a network. But we're going to give you an analogy that maybe you're familiar with already, right? Because if it's the first time you've seen networking, maybe this is just all fresh to you, and you're like, what do you mean that it's a unique identifier? Let's kind of compare that back to something else. So I want you to think about like mail, right? When your mail is delivered, all right, you have a street address, right? Street addresses, and I'm not talking about the whole entire thing with zip code and all. I'm just talking about the street address itself, right? Not the whole mailing address. Well, what is a street address comprised of? Well, it's comprised of what? A house number, and it's comprised of a street number or street name, if you will, right? Doesn't necessarily have to be a number, it could be a name, all right? And when a mail truck needs to deliver to your address, well, what do they first have to know? They first have to know what street you're on. So they got to locate the street, and then once they locate the street, now they have to differentiate your house, let's say if Ronnie's my neighbor, from Ronnie's house, right? So what does that street address have to have, all right? Well, it's got to have a street name, but on that street, it has to have a unique identifier as well, right? It has to have a unique house number, all right? And that's how we differentiate, first of all, houses that are on the same street, and then the uniqueness of the house within that street. Now, don't throw duplexes or triplexes at me. We're not going there. We're just talking about individual houses. Now, how would that analogy, how can we bring that over into our networking? All right, well, I want you to think of a network, all right? And I want you to think of your IP addresses as kind of like street names, all right? If I look, I know that a computer is going to have a unique network identifier, right? If two computers are going to be considered to be on the same network, then like the houses that have to have unique identifiers, and I need to identify them on the same street, they have to have the same street name, right? And that's going to be important. So I want you to think of the two components within an IP address are what's known as a network ID and a node ID. And I want you to think of your network ID as kind of like being your street name. All right, if two computers are going to be considered to be on the same network, like our houses, they have to share the same network identifier. All right, street name. But how do we uniquely identify two of these computers within that same network? Well, let's go back to our house numbers, right? Just like a house, sets of houses have to have unique house numbers to be differentiated on the same street. Your nodes, in this case computers, but understand that many things can have IP addresses, this host or node on this network must have a unique identifier as well. So like our house identifiers, that's what's known as a node ID. So an IP address is comprised of two different things. All right, it's comprised of a network identifier, network ID, and a host ID. All right, so how do we get to this point, right? Well, we do that by a couple of things, a couple of rules you need to be aware of, all right? In order for two computers to be considered on the same network, all right, they have to have the same network ID, all right? And they also have to be uniquely identified. Let me make sure that I put that. They have to be uniquely identified. They can't have the same house number. They can't have the same node identifier, right? So let's say, for instance, Ronnie and I are neighbors, and I maliciously go out to his mailbox and I peel off the stickers on his mailbox. I wouldn't do that. I don't want to go to jail. And I put the same address as my house. Well, I want you to go back and think about it. What would happen if somebody was trying to deliver mail to our street, and they deliver mail to me, and then they come to the next mailbox and it's got the same house number? Well, your mail carrier is going to get a little confused, right? We're going to have a conflict. Well, you have to understand that in networks, your nodes have to have those unique identifiers as well. They cannot have the same node ID or host ID, as it's called. All right? And in order to be considered on the same network, there's another thing that they have to have. They both must share the same subnet mask. And that's where the subnet mask comes into play, all right? The subnet mask, we're going to get into. It looks like we're running a little bit short on time on this episode, but when we come back in a part 3, we're going to tell you exactly how to apply that subnet mask so you can identify what network you're on.
All right, Wes, well, thank you for helping us to at least get started with the idea of binary and decimal conversions. It is a skill that we have to get ready for as we prepare for the Network Plus exam, and you do need to practice this so that you get quicker at it for the exam as well. And then, of course, we broke into the concept of what an IP address actually is and where it actually does break those 32 bits apart. And a portion of it's going to be your network ID and a portion of it's going to be your node ID. And we still need to see how that's going to be accomplished inside of the computer world as well. And that will be coming up in that part 3 that Wes mentioned. But this is a great place for us to sign off then. So for IT Pro TV, I've been your host, Ronnie Wong.
And I'm Wes Bryan.
Stay tuned right here for more of the CompTIA Network Plus shows.
Thank you for watching IT Pro TV.